Hey, so today we're doing 8-6, solving rational equations. We're going to do a couple examples together, but really it's not, I mean, you've kind of laid the foundation with 8-4 and 8-5 to be able to do these pretty easily. But we're going to spend 2 days working on them, and hopefully that gets you a good start on your test, or gets you ready for your test on Friday. For those of you that are going to be gone on Friday, please make sure that you talk to me today. You need to get your practice test so that you can complete it early so you can take your test prior to spring break. Okay? I know some of you have already spoken with me, but do that today. Actually, as soon as I'm done talking here, raise your hand so we can get that taken care of. Okay? Your quizzes aren't graded yet. Hopefully by tomorrow or Wednesday they'll be done. All right? Questions? Very good. Spend a few minutes, at least get those problems copied down. For example 1, give yourself room for those 2 problems on question 3, and then example 2, question 4, give yourself a little room for that one. We'll start out with question 3. You don't have to, maybe just hold up on question 4 for a minute. Okay? Okay, can I get your attention back up here? Let's go ahead and let's take a look at 3D. All right? Some good discussion about it, but when we're looking at a problem like this, if you think back to, let's go back to, say, a different problem. So this has nothing to do with this other than it's a similar type of problem. If you're thinking of your previous learning on how you'd solve this type of problem, if I said I had like x over 5 equals 4 over 3, how would you solve that?
Cross multiply.
Brooks, what do you got?
Cross multiply and divide.
Cross multiply and divide. Okay, so we go 3x equals 20, and we divide by 3, so x equals 20/3. Right? All right. What is it called when you have 2 fractions equal to each other?
Proportion.
Yeah, a proportion. Good job. It's called a proportion. Well, this is a fraction. It's just a weird-looking fraction. And this is a fraction. It's just a weird-looking fraction. So what you have is a proportion. You're not adding anything to your fractions on either side. Okay, you have a numerator and a denominator on both sides. So proportionally, you're dealing with the same idea. Okay, so let's cross multiply. The divide is a bit different, but let's at least get the cross multiply down. That gets rid of the fraction. Okay, so we get 2 times x squared minus 2 and negative 2 times x minus 3. Okay, just make sure you have those in parentheses there. All right? Any questions on that? Quit holding hands, guys. Thank you. All right? Well done. Unbelievable. Negative 2 and 2. What can I take out of each of these? Okay, divide them each by 2. You don't have to. You could distribute the 2's, but you could divide by 2 also, right? If we divide each side by 2.
So negative x minus 3 and x squared minus 2.
Good. Yeah, you get negative x minus 3 equals x squared minus 2.
Would it be better to distribute out that negative, or would it be better to just leave it?
Yeah, we're going to eventually have to distribute it out, so we might as well bring it in. Okay, so bringing in that negative 1 there, it gives us negative x plus 3 equals x squared minus 2. And at this point, some of you will look at that and you'll know what you're going to have to do to solve. What type of problem does that become?
Quadratic.
Becomes a quadratic. Okay, so we have that x squared over here. We're going to bring that x over by adding x. Bring that 3 over by subtracting 3. Okay. So if we deal with that, we've got to add that x. We don't have a like term there, but we do have a like term with the subtracting 3. So we get x squared. Gets rid of plus x. And then that's gone. We have minus 5. All that equals 0. Okay? How many made it that far? Good. How many did it that way? Okay, so there are different ways to do it. All right? Questions? Okay, Can I factor?
Yes.
No.
Two things that multiply to make -5 and add to 1.
3 and -2.
3 and -2 add to -5.
Oh, wait.
No, yeah, they don't even add to -5. Thank you. -3 and -2. Yeah, we can't. Nothing we can do. So what do we have to do here? Good. Yeah, you can do a few different things. With quadratic formula, let's go opposite of b, plus or minus b squared minus 4 times a times c all over 2a.
Hey, that's a Canadian.
Hey. All right. So we get -1 plus minus square root of 1. This is a,
Plus.
that's a positive 20, right? So plus 20 over 2. Good. Gives -1 plus minus root 21 over 2. Break that apart now. So we get -1 plus root 21 over 2. And -1 minus root 21 over 2. Which gives us 1.79er approximately. This gives us -2.79. All right, so those are our x values. Dude, that's quite the problem. I think so. All right. Hey, you should always test them. You plug them in. They should work out on this one. Okay. So 1.79, -2.79. Make sure you put it in set notation. Round to the nearest hundredths. All right. I guess that's approximately that. Any questions? All right. Nick has a question. What's your question, Nick?
What?
That's not the right question.
But what is the question? What is life?
That was the question. What?
What's life? Exactly.
All right.
42.
Hey, moving on. 3A. Tell your neighbor what you're going to do first. Okay, time's up. Volunteer. Noel. Cross multiply. Hey, when time's up, time's up. Paying attention. So we get -4 times x plus 2. And that is equal to,
15x plus 2.
good, 15 times x plus 2. What should we divide by? Tell your neighbor.
Oh, x plus 2.
No, you can't.
Okay, volunteer. What should I divide by? Come on, be brave. Yes? Good. Jacob says x plus 2? Yeah. Let's take out that greatest common factor. That pulls out on both sides. That gives you cancel. And Elizabeth said you get no solution. Someone else tell me why we get no solution. Zach?
You just went through the entire thing, you get x equal to -2, and it can't equal -2 because then it would be a 0 denominator.
Okay, so if you actually work through it a different way, you could get x equals -2. Hey, too much talking. We get that -2. -2 plus 2 gives us 0 here. Based on this right here, how come it's no solution? Brooks?
Because -4 is not 15.
Yeah, because -4 is not 15. They're not equal. That's not true. I'm pretty sure. All right. Okay, hey, let's look back at these two problems. Need your attention back up here. Okay, looking back at these two problems, on both of them, I've pulled out a number before distributing in, right? Here I pulled out an actual value of 2. Here I pulled out a quantity. Why are you still talking? Thank you. Okay, here I pulled out a quantity. Here I pulled out an actual number. Look for that today. Okay, we're to that point now where you should be looking for that. Makes the problem easier. You could solve it a different way, but it makes it easier if you take that piece out. Okay? Any questions? Okay, let's move on. Let's try 4A. 4A. A. All right. How many of you have started this one? A couple of you started. I wanted you to at least get a copy down. So, checking out 4A. I want you to tell your neighbor what you're going to do to solve that problem. Okay, what are some ideas that you had? I heard a few of them. What's one?
Move the 3x plus 1 over to the side with the 1 on it, and since it's just 1 over 1, it'd be 3 over x plus 1, and the 1 go away.
Okay, so you're like adding this over to this side? Okay, you could do that, yeah. And then you'd have a proportion, right? If 1 over 1 was being multiplied, it would go away. It's not going to go away. 1 over 1 is still 1. So if you move that over to this side, you'll have 4 over x equals 1 plus 3 over x plus 1. But you could do that, and that's kind of how we'd try to start isolating x if we're thinking on how we'd solve problems with fractions. What's another way we could start it? Yep.
Multiply each side by the least common multiple.
Okay, so multiply each side by the least common multiple with the common denominator. Good.
Squared plus x.
All right. Anyone else? How many chose one of those two ways? Okay, how many went multiply by the least common denominator? Okay, so that's probably the easiest way. If we move this over, I understand what we're trying to do, trying to get that proportion, but it might make it a little more difficult. So what I want you to do is I want you to tell your neighbor what the common denominator is going to be on that.
X squared plus x.
Okay, what's the common denominator? Yes? Yes?
X times the quantity of x plus 1.
All right. Julia says x times quantity of x plus 1. That is correct, Amundo. Hey, this has the x, right? That has the x plus 1. So if I group those and think of it that way, I have x times x plus 1. Which means now, if you're looking at these, we've got to start looking at these fractions now as two different pieces. Okay? This piece right here needs what part of this?
X plus 1.
X plus 1. And this piece needs what part of this?
X.
And we got to think of this also, right? Because it's a term. So we got to multiply every term by that. So this also has to be multiplied by it. So what does this need of this? Yeah, it needs both pieces, right? Okay, so if we rewrite that problem, make it look like that, you're multiplying each part by either both pieces here, the x and the x plus 1, or if it has the x, it just needs the x plus 1. So the 4 over x has the x, so we're going to multiply it by the x plus 1. Remember, that's the special number 1. X plus 1 over x plus 1 is equal to 1. So it's like multiplying it by 1, so you're not changing the value of 4 over x. Okay? And this part right here has the x plus 1, so it needs the x. Okay? Once again, that's special number 1 there. A lot of holding hands today. I
Yeah,
don't know
we're
what's
just
that.
doing an awesome thing because we solved the problem.
Oh, it was like a cool handshake.
Yeah, it's a cool handshake. That's what it was.
Okay? Hey, and the one needs both pieces, right? So you're going to multiply that by x over, or x times x plus 1 over x times x plus 1. Okay, and what's the other thing I did? I made this subtraction into a positive, which means that 3 became negative, so I'm adding the 2. Any questions up to there? No? How many are with me? Okay. So from here, on top, what do we get? Numerator?
4x plus 4.
Okay, 4x plus 4. So distributed there. Okay, the denominator is?
X times quantity of x plus 1.
Yeah, it's the common denominator. We're adding
Negative 3x.
-3x over
X times quantity of x plus 1.
That's equal to that whole,
X times 20 of x plus 1 over x times 20 of x plus 1.
yeah. Holy cow, man. We now have a common denominator.
Right?
That seemed fun. Woo!
Amen.
Yeah.
Are there, I might be getting ahead, but are there implied parentheses on the 4x plus 4?
There are.
Okay.
Yep, there are implied parentheses here, but when we're adding like terms, which is our next step,
They can go together.
right, we can combine this now. So we have 1x
X plus 4 over x squared plus x.
over x times x plus 1. And that's equal to that.
Can you cross cancel?
In cross multiply. Now we could have left. Well, we're going to get to a point here where some of you are going to go, man, there is a much easier way to do that.
Yeah.
Okay.
Leave it.
But from there, what do we know?
Cross multiply and divide.
We could cross multiply and divide. However, yeah.
The x times the quantity x plus 1 over the same thing, that just equals 1.
That does equal 1. Hey, but the way we've set it up, hey, this is a different problem again. But if I look at, say this, if I have 1 over 4 equals x over 4, what is x?
1.
How do you know x is 1?
Because it's the same denominator.
Same denominator. Notice? Same denominator. So what equation do we have there? Yeah?
Well, you could do the bottom denominator of the x plus 1 and the top numerator of the x plus 1 divided by x plus 1 is x plus 4. So you say x plus 4 times x plus 4 divided by the x plus 4 that you just multiplied.
All right, hold on. That's just way too
The answer is x plus 4 is equal to x plus 1.
Okay. Yeah, let's just go with the last thing you said. All right? The x plus 4 is equal to the x plus 1. All the other stuff, you were on the, whatever you're saying at the beginning was right, but
One through the entire thing.
yeah. All right? So these are the same, so those have to be equal if the fractions are equal. Okay? Hey, once again, there's still a much easier way to solve this problem, but we're going to go through this process. Okay? Plus 1x there, right? Okay, it's quadratic again. Right? Sure? Yeah?
Difference of two perfect squares.
All right, well, let's move this over. Let's subtract x. So we get 4 equals x squared plus 0. Right? Subtract x. And now we get x squared equal, 0 equals, subtract 4, x squared minus 4. That's difference of two perfect squares? Yep. So what do we get? We get x equals plus or minus 2. We could have left the 4 over there and taken the root, but x equals plus minus 2. All right? Hey, you guys, there's a much easier way to do that problem. All right? Let's try that easier way on this next problem. Everyone write down letter B, okay? Write down letter B. That guy right there. Whoops. Okay, so before we go through this other process, I want to first emphasize that you could do the problem the same way. You can find the common denominator and go through that process again. That would be okay. In fact, we really didn't have to touch the 1 on this one. Like we could have left it a 1. We didn't have to we didn't have to find the common denominator on that side. Okay, but I was trying to set you up for this other process. Not to mention at the end it makes it real easy when the denominators are the same and you have a proportion. Okay? However, there's an easier process. I want you to take about a minute and see if you can come up with the easier process on this. Okay? Talk about it. Don't just sit around and wait. Give it a shot. Hey, wrap up discussion. Hey, I kind of alluded to it. Need your attention up here. Go ahead. I kind of alluded to it when we were talking on the last problem, when I said multiply by the common denominator, and it's actually on the last one we found the common denominator. We're going to actually multiply by the common denominator. We're going to multiply every term by the common denominator. Okay? That is easier. All right? Notice if we take a look at this last problem, we multiplied every term by 1, essentially, right? Everyone with me there? If I would have went back through this last problem, and just stay with me on what I'm doing here. On this last problem, if I would have said, you know what, rather than multiplying by 1, if I multiply this by the common denominator of x times x plus 1, and get rid of that, and multiply this by x times x plus 1, and get rid of that, and multiply this by the common denominator, but get rid of that. So now I'm not multiplying by 1 anymore. I'm actually changing the value of each of these. But remember, as long as you do it to every term, you're okay, right? It's like if I took an easier problem and said, hey, I have 4 plus 2 equals what?
8.
Let's go with 6. Holy moly. All right, and I say, well, you know what? I want to make that twice as large, or 3 times large, so now I'm going to multiply everything by 3, just like we did in systems, but I have to multiply everything by 3. So that now gives me 12 plus 6 equals 18, and that works, right? Okay, that's all you're doing here. However, when I do that, notice when I multiply this by that, what cancels?
The X.
The x cancels. And so I get just that. Right? I no longer have that. And when I multiply this by this, what cancels? X plus 1. And so I just end up with this. And when I multiply this by that, I get that. So by multiplying by just the common denominator, it wipes out all your fractions. So you're left with this, which is pretty much where we ended up with, what we ended up with down here. But we get 4x minus 3x is x plus 4 equals that. We didn't even pay attention to this, right? How many are with me on that? Okay, so rather than multiplying by the special number 1, let's multiply by the common denominator. Now, on mine, I've kind of given it away here, but the common denominator, you've got to factor this. You get x plus 2, x minus 2, so the common denominator is x plus 2, x minus 2. You have the minus 2 in both and x plus 2 there. So if I multiply each of these by the common denominator, then I should end up with eliminating a fraction completely.
So multiplying by the common denominator, meaning the common denominator over 1.
Right. So I'm going to multiply this first term right here by just the common denominator. So I'm going to multiply it by x plus 2, x minus 2 over 1. You guys with me there? Okay, and I didn't give myself a lot of room on this one, but make a smaller equal sign there. But I'm going to multiply this piece also by the common denominator of x plus 2, x minus 2 over 1. And then I have to multiply this piece also by the common denominator of x plus 2, x minus 2 over 1. I see some of you writing frantically, so pause here. Some of you not writing at all. You already did it. Okay, how many are caught up? Okay. I want you to cancel right now what you think cancels and write your new equation down here. Make the problem easier. Makes it look a lot better, hopefully, if it went right. So let's see, the x minus 2's cancel. What am I left with from this box? X plus 2. So x plus 2 times 1 over 1 is just x plus 2. Plus, what cancels here? Yeah, everything on the bottom. So I'm left with minus 3x. And here, what cancels? Yeah, nothing. So I'm left with 6 times. Yeah, and I'm just going to just, it's x plus 2, x minus 2, right?
Yeah.
Usually I would just multiply that out and be x squared minus 4. Okay, so let's simplify this a bit. A plus and a minus makes a negative. So I have x plus 2 minus 3x equals, this becomes x squared minus 4 times 6, which is 6x squared minus 24 equals x minus 3x is negative 2x plus 2. We're going to get a quadratic again, right?
Yeah.
Is there quadratical? Oh, a girl yesterday at driver's ed, side note, she came in, she was doing her test. She was in Trig last year. She showed me one of the funniest jokes. Just wait until chapter 9. I'll find the joke. I mean, you'll get it. And some of you, because you won't get it right now. No. Okay, I'll find it and I'll put it up here and you'll look at it and like, you might chuckle, but you really won't get it. But later you'll actually, oh, that'd actually be good because then we'll be in the middle of a lesson one of those days and you'll be like, I get it. It'd be a good chuckle then. We like the chuckles. All right, sorry for getting us sidetracked. We needed a brief moment there.
Minus 26.
Okay, so let's add that 2x over. So we get plus 2x minus 24. And we'll bring the 2 over. Subtract 2. We get 0 equals 6x squared plus 2x minus 26. Yay, now it's a quadratical. Okay, what do we take out of that? We take out a 2. 3x squared plus x minus 13, which did that help us at all? No. Not really. It just means when we use the quadratic formula, we don't have to worry about that 2 anymore.
Oh, good.
Okay? It didn't disappear. It's just we don't worry about it when we're solving for x now because there's no x by it. Use the quadratic formula here. I know everyone can do the quadratic formula, so I'm not going to make us go through that process right now. Okay? The solutions you should come up with, though, when you're working on this at home just for fun, is 1.92 and negative 2.25. Okay? I just did that in my head real quick.
Oh, dude, nice.
Yeah.
So good.
Either that or I looked on the paper right next to it. All right. So use the quadratic formula to get that.
Yeah.
Okay, everyone rate themselves 1 to 5 right now.
At least.
At least 0. Okay, very good. Let's try one more problem. This off the example side. Maybe multiply by a common denominator to get rid of your fractions now. Okay, it's the last problem we're doing together. Ready, go. Hey, I realize some of you aren't done, but in order to start this problem, what are we multiplying by?
30.
30. Multiplying each term by 30. This one by 30. This one by 30. I'm going to change that to plus and negative there. Okay? So that one by 30 and that term by 30. Now, the way we got that, 5, 2, and 3, the least common multiple is 30. Okay? All right, so if we cancel, this is like a 30 over 1, right? We cancel here, 30 and 5. 5 cancels. What does 30 become? 6. So we get 6x minus 30. Okay? We think of this as a fraction. We cancel the 2. What does this become? 15. So we get plus a negative 15 or minus 15 equals, think of this as a fraction. What's this become? 10. 10x plus 50. Now how many made it that far? Oh, well done. That's very blurry. Okay. 6x minus 45 equals 10x plus 50.
Subtracting 6x, add 45.
Okay.
3 more for 3.
Negative 45 equals subtract 6x. You 4x plus 50.
Plus 95.
Subtract 50 over.
Right. Make that the left.
4x equals 95.
-95.
Negative style.
Divide by 4. Get
Divide by 4.
negative 23.75.
X equals
Negative 23.75.
negative 23.75.
Or negative 95/4.
Shouldn't use a pen. Unbelievable. Mr. Kolstad would not be pleased. Mr. Kolstad was my high school math teacher. Hey, how many got that? Well done. Questions? All right. Once again, need your attention up here. Thanks. Your assignment, 1 through 21. Okay? Example side. Now we've done number 14 already. So you could just put the answer there. But notice on this, we talked about 2 different ways of solving. First, in example 1, what types of fractions are they? What is this type of problem called? It's called a proportion. Solve proportions by cross-multiplying. That's how you get rid of the fractions. That's the easiest way. You could multiply each side by the common denominator, do the same thing. So if you don't want to remember 2 ways, that's all cross-multiplying is really doing. It's multiplying by a denominator, a common denominator. Not always the least, but a common. Yeah?
So 1 through 6 we can use the cross multiply.
They're proportions. Anytime you have a proportion, so like number 17, that's a proportion. Are there any other proportions down in example 2?
No. Wait, yes,
17. Hey, you guys, and sometimes it's easy enough to look at problems and try to simplify the problem first. Right? When I'm looking at this, I can't combine any fractions here because none of them have common denominators. But there are some, like this one, that has a common denominator. So this fraction over here is actually what?
2 plus 1.
It's 3 over x equals 3. Okay, cross multiply there. Or multiply both sides by x. Hey, this has a common denominator already. Combine it. Or excuse me, you could move it over, right? So bring it, you could subtract that over and get 1 over x minus 1. Okay, that one doesn't, this one does. Okay, so look for those common denominators also. That's another way you can deal with them. All right, so 1 through 21, do your best. We'll go through questions on it tomorrow.